Hey, welcome back. As you recall, when we last ended, we'd just done the scripting to make our character move back and forth. Now the obvious problem here is we need him to flip directions when we hit the controls. So let's go ahead and do that right now. So first off, let's look at how we can do that in the inspector before we go to our code. Now I can think of two ways to do it, and I think I can pull it off in code two different ways. So one is with scale. Let me zoom in on my character here. If I change this x to -1, that'll scale him in the other direction. That's one way to do it. And the other way is with the sprite render, I can just flip x. So there's two different ways to do it. I'm actually going to show you guys how to do both. And one is a little bit harder than the other. So you're probably going to want to do one over the other, but I think it's really important for you to know that in coding, there's multiple ways to do the same thing. So let's go over to our code and take a look. Okay, the first way to do it is with x, changing it to -1. So let's go ahead and do that method first. So step one, we're going to have to grab that object and declare it as a variable. So let's go transform, because that's what the game object is called, and we'll call it myTransform. So this is just a variable we're declaring. Next, we need to know if we're facing which direction we're facing. So we're going to create a Boolean, which is a yes or no, true or false. Boolean called facing right. And we'll make that true, because when my character falls in, he's facing right. Next, I have to actually go and grab, just like we grabbed this rigid body 2D object and assigned it to our variable right here. Now I need to do the same thing, but assign this variable the transform object. So we do that the exact same way. We go myTransform equals get component, and then transform. So it's kind of the same process. We set a variable that is a transform type, and then we go down here and assign that variable this transform component that's on the game object. So next we're going to go into update, which you know is called every single frame, and we'll have to do a little logic here. So if move is greater than 0 and not facing right. So the code goes in and says, is this move greater than 0? Which would mean we're hitting the move arrow to the right, and we're not facing right. Because if that's the case, we need to flip it, right? Because that would mean we're not facing right, we're facing left. So if we're moving right, if we're hitting the right arrow key or the D key, and we're not facing right, then we need to flip it. So I'm going to create a custom function called flip, and we're going to do that in a second. But for right now, it's red because we haven't created this function. We're going to create it down below in a second. But first, I want to finish this. Else, if move is less than 0 and facing right, then what happens? Then we need to flip again, right? Because that would mean that we're hitting the left arrow, but we're facing right. That means we need to flip it. So we'll call our custom function again. Now, I'm just going to pause for a second real quick and let you know that programming seems hard at first. It seems really difficult. You may have to pause this several times. You may type something wrong, just the slightest wrong syntax, and your code will break. And it'll be frustrating, and you'll think, I can't code. I used to say that to myself, but I promise you, you can learn. And you'll even find it fun after a while. Once you get good at something, you find it fun. It's not fun when you suck at it. But that's why you just gotta slow down, think through it, ask questions, get on the web, and keep coding, because I promise you it gets easier with time. Okay, so I mentioned that this is a custom function, something we need to write. And basically all a function is a bit of code that we write that we can call anywhere by just saying the name of the function and having these parentheses right here. That's how you call a function in most coding languages. So Now we need to write that code. So let's go down below, right in here, and this, we'll just say this is our custom function to flip our character. Okay? So I just am going to go void because it's not going to return anything. Remember, we talked about void means our function doesn't return a number or a boolean or anything like that. It just does some work for us in this case. So flip, the name we are going to name it, and then we put our code within these brackets right here. So facing right, that boolean we set at the top, first we need to tell it it's no longer facing right. All this bit of code does right here is it reverses whatever is in this boolean facing right. Right now it's true, so the first time it gets called, it'll be not true. And you have to do that so that every time it's called, it flips it the other direction. Okay? So now we need a little bit more logic code here. If myTransform.localScale.x is greater than 0, and if that's the case, then we're going to assign myTransform.localScale equals new vector 3 -1 1 1. Okay? Now I know this seems complicated right here. In fact, it took me a while to figure out how to do this because let's just go back. I'll save real quick. Let's go back to our program. And when I go into the inspector here, the way dot notation should be working, the way I thought it should work was I'll grab the game object that is transform, and then I'll go scale, and then I'll just scale x. However, in Unity, that's not how it works. I have to create a new vector to scale all three of these at once. And I don't know why that is. I think that's kind of goofy, but that's just the way they built the software. And they're calling it local scale, not scale. So I had to actually get online and do a little research to figure out that myTransform.localScale, and that I had to assign a vector 3 so that I had to change all three values at once. I couldn't just go local scale dot x equals -1, which is what I thought. That sounded really easy and simple to me. I don't know why it's built this way, but it is, and it took me a while to figure it out, but that's okay. That's what coding's all about. Okay, so let's finish this off here. Else myTransform.localScale equals new vector 3 1 1 1. And all we're doing there is saying return it to its normal values for facing right. This means it's facing left. This means it's facing right. So it seems like a lot of code, but it is kind of simple. It seems confusing to have to create a new vector 3 instead of just saying make x equal to -1. That's how I would have written it, but I am not a genius like the Unity people. So whatever. I'm going to save that, and hopefully, if we did everything right, this will be working. How you betting? I'm going to hit save. I'm going to hit play. And what we should get here is when I hit the left arrow, he turns around. Boom, now we're getting somewhere, okay? Now I'm going to show you an even easier way to do that, okay, in the next video. So I'll see you there.